All right, good morning. Welcome back to your chemistry class. Okay, so you just watched some stuff about how to read a box on the periodic table. So we looked at the example of nitrogen and we kind of parsed it. So we figured out there's these four things inside each box. So we looked at nitrogen in the last video, but you could look at aluminum. Some of these you've heard of more often than other things, but even copper has the same stuff in a box. It's got the atomic number of protons up in that top corner. Got the symbol, one capital letter, one, or the rest are lowercase letters. The name in English, so may or may not actually match the symbol. And the average atomic mass, right, which we will delve into in more depth later. Okay, good. So our next question is, we figured out the particles. Yesterday you figured out the subatomic particles in your atom. Every atom has these things as the subatomic particles. And today we want to draw our atoms. Okay. That very next column is going to give you some hints about how your drawing will look. Different particles live in different places. So we'll just do a little bit of thinking this through, and then we'll go back to here, and this will help us draw a bunch of pictures. Okay, let's do it. Let's give yourself a title. So title for today is drawing Bohr structures, or how to draw Bohr structures, whatever you want. Let's go with how to draw Bohr structures. And for here and for now, we'll figure out two types of structures. We're going to do Bohr structures today and Lewis structures tomorrow. These are both people's names. Bohr was a person, Lewis was also a person. I use them in part, like as the names of these things, in part because the name itself gives you some hints about what the picture is going to look like. So you're going to look at these are just like ways to remember them. Look at the name of the structure. These are Bohr structures. Look at the vowel in the name. Bohr has an O in it. Your Bohr structures are all your Bohr structures are going to look like circles. And in case you forget, you can just check that name, and all Bohr structures will look like circles. And we'll get to it more tomorrow, but Lewis, Lewis, has an I in it. All Lewis structures will look like dots. Okay, but I'll say that again tomorrow. For today, Bohr structures will all look like circles. Look like circles, just like the O in Bohr. Okay, there's a chance that you've drawn Bohr structures before, and you may be like, oh, like I kind of remember like circles and drawings of atoms and stuff like that. Let's do it. Okay, on the inside of Bohr structure, but these are all Bohr structures. The inside of a Bohr structure contains the particles that are on the very inside of the atom. Okay, so look at your particles table from yesterday, and your question is, which particles are in the very inside center dense little part of the atom? Okay, we've got three types of particles. We've got some protons, electrons, and neutrons. And the second column is, where are they in the atom? Two of these particles are in the nucleus. Those two particles in the nucleus in the very center, those are the particles that are in the nucleus of your Bohr structure as well. that makes sense. So the inside of your Bohr structure is your nucleus. And your nucleus, just like yesterday, still contains protons and neutrons. Okay, great. We sometimes use little symbols for these particles. Did not include it on your chart, however, we did. We gave you some clues here in this next column, this charge thing, to reference that. Your protons can have a little symbol of P for proton. That makes sense. And the charge written right there. So if you see something that is a P with a little plus sign, that means proton. So P with a little plus sign is proton. Neutrons are neutral, so we will give them the symbol N with a little 0. And that just means that the neutron particle has a charge of nothing. No charge, no positive, no negative. Neutrons are neutral, they have no charge. Oh, I just noticed that this kind of looks like no. A neutron with 0 charge kind of looks like no. Neutrons have no charge. Great. Okay. So when you go to draw a Bohr structure, on the inside, little tiny nucleus on the inside, we'll put how many protons, and I'm not gonna get us too deep into how many neutrons. I want to show you how many neutrons, so let's do it. Okay, so on the very inside, let's choose an atom with like not that much. Let's draw hydrogen first. So example, hydrogen. On the inside of our hydrogen is our nucleus. Nucleus inside. And how many protons? We're going to have some number of protons and some number of neutrons. That's off screen. Some number of protons, some number of neutrons. To figure this out, we look at our box on our periodic table. That will show us how many protons anyways. So here's our box, there's our hydrogen. That number up in the top corner is how many protons. Alright, so we've got 1 proton in hydrogen. We did choose a relatively simple atom here. We've got 1 proton. And how many neutrons? To find how many neutrons, we will take, to find neutrons, number of neutrons, take the mass minus protons equals neutrons. And then round to the nearest whole number. Okay, let's roll that to write down. But here we go, we got this. We're doing the example of hydrogen. We're going to find how many neutrons. We're going to take the mass number minus the protons to find the number of neutrons. Off we go. Here's our hydrogen. Here's our mass, 1.01. So 1.01 is the mass of hydrogen. And we can just do this like this. No, that doesn't go on the screen. Okay. There's the mass of hydrogen is 1.01. Down here, we want to find the number of protons in hydrogen. That's the atomic number up here. Number of protons, so mass minus protons equals number of neutrons. 1.01 minus 1 is 0.01. If you were to round that to the nearest whole number, we would say 0.01 is closer to 0 than to 1. So in this case, we round that to the nearest whole number, and that is 0, no neutrons. So, and what that tells us is that most hydrogen atoms have no neutrons. Some hydrogen atoms have a neutron, but what that 0.01 means, like when we take the mass number minus the protons to find the neutrons, mass minus protons, that's going to tell us most hydrogen atoms have no neutrons. And we'll just leave it there. We could dive way deeper and figure out where all of these funky decimals come from. But in short, all of your funky decimals are from some atoms having neutrons and some atoms not having neutrons. And it's just like anything else, like some atoms just have more mass than other atoms. And these are all the average mass of every known element, every known atom that we know of that element. This is the thing we're not going to get real deep into virtually. For here, take the mass with all those decimals minus the protons, round to the nearest whole number. That's going to tell you how many neutrons. So in our hydrogen example, we figured out we took mass minus protons, rounded to the nearest whole number, no neutrons. So over here in this nucleus, we're going to say 0 neutrons. Okay. All right. That's the inside of our Bohr structure. The outside is where it's going to get more interesting. All right. To draw the outside of your Bohr structure, that outside part is where most of the exciting stuff happens. So the outside, we just put 2 of our 3 particles on the inside, in the nucleus on the inside. The particle that we'll put on the outside is the other one. So here are all of our particles. We just put protons and neutrons in the nucleus, where they live. Good. This one, these electrons, are what we're going to put on the outside in the electron cloud. Off we go. Alright, so on the outside, we have got the electron. Outside gets electrons. Okay. And you may remember that Bohr structures can look like, that they look like circles. We got that figured out. You might remember from a past year that you sometimes wind up drawing like multiple circles. Sometimes. This is just a memory of the past that might ring a bell. Bell. There we go. That might ring a bell from the past. So in Bohr structures, your electrons live on circles, orbitals. See, part of why I am like tripping up just saying this stuff is that we've actually updated the model since Bohr. And coming soon, in just a few weeks, we're going to be like, this is so first week. We've got like this updated structure. It's still important to learn because Lewis structures are actually still really helpful. But this is actually, we recognize this to be an outdated model by now. But we're going to learn it anyways because it's going to help you see a lot of stuff even though we have updated it since then. Okay. There's a way that I do this in person that is, I think, fairly easy. But we're going to go for it anyways. the number of circles that you will draw is based on the location of your atom on this giant grid of all things. So based on where your atom is, the number of circles is based on number of circles you'll draw. Okay, based on where the element is on the periodic table. Okay. And in some ways, this whole quarter is all about learning how to read this kind of like a book. So like you can think of this as being a literature class where instead of like chapters and quotations and like feelings and, you know, like book things, what you do in English class. Like English class is all about reading things also. And in some ways, we spend an entire half of high school chemistry figuring out how to read this like a book. And off we go. Here's your first step in that general realm. The number of circles you'll draw for your Bohr structure is based on where the element is located on the periodic table. If the element is located on the top row, you will draw one circle. And I zoomed out real big because the top row has some like space in between. We'll figure out why. In just a few weeks you'll know like with total confidence why there's all this space in between. But this top row is this right here. So if you are drawing one of those two elements, hydrogen or helium, you will draw one circle because those elements are in the top row. They're in row number 1. You can label this here. They're in row number 1, so you're gonna draw one circle. Again, it's zoomed out so you can see across all of that space, but if we zoom in to see our example hydrogen is in row number 1. You can write that right on your table and keep it forever. So hydrogen is in row 1, and we will draw one circle when we draw hydrogen. Okay, so to write that down, let's say it's the electrons. The number of circles you'll draw is based on where the element is on the periodic table. Elements in the first row get one circle. Elements in okay. And you might get a hint from how we just wrote that, what the pattern is going to be. Elements in the first row get one circle. Make a guess here. Elements in the second row. And let's figure out what that is. So elements in the first row, zoom way back out to see the whole first row. Zoom out even more than that. Okay. So elements in the first row are these two on that very top row. Elements in the second row, that is row number 2. Lithium, beryllium, jump across another gap, boron, carbon, nitrogen, oxygen, fluoride, neon. So elements in that second row, make a guess, and you're going to get it right. Elements in the first row get one circle. Elements in the second row get 2 circles. Keep going with the pattern. Elements in the third row get here's your third row. So our first row is that very top row. Our second row is the second row. Our third row is the third row. Elements in the third row get 3 circles. Okay. Very good. I'm gonna do some of these little marks mean just continue as above. Everything in the fourth row. So all the elements in the fourth row get 4 circles. Your fourth row is here. Your fourth row is this first row where it's kind of filled in all the way across. You've got elements in this part also on your fourth row. Everything in that fourth row gets 4 circles. Everything in the fifth row gets 5 circles. Everything in the sixth row gets 6 circles. Everything in the seventh row gets 7 circles. Something happens there. Let's fill in over here and then figure out what happened with this. Yeah. So if is it cool if I just say I'll write it out. Elements in this is an example of a time that you could use the video like a video. You don't have to watch me write this 3 more times. You can fast forward to after I'm done. I'm just going to fill in this table. Fifth row, get 5 circles. If you would like to audio hear me say it a bunch of times, go for it. It is up to you. Elements in the sixth row, give it 6 circles. Elements in the seventh row get 7 circles. Okay, great. Good. If you're still going on your tip, feel free to pause and finish your table. You'll notice that I stopped at 7. And if you're going ahead and you're like, yeah, but there's 8 and 9 and we've got a pattern going, like, why stop a good thing? There are 2 more, like, rows down here. They've done this weird thing. If you've been in my classroom before, which some of you have, you may or may not remember across that back row, we've got that giant rainbow periodic table across the entire back room. When we do it correctly. In part because I've got the entire wall of a classroom to work with. This piece of paper, if they were to print this page correctly, they would need to print it across 2 pages. Like this thing here, as if this doesn't look intimidating enough, what they would have done if they had printed it correctly would be to print all of these elements inside of these rows. But think about how, like, zoomy-in and, like, microscopic you would have to make that. Like, if all of this was printed right there, there's actually another break in your table. There's actually a break in your table right here. Like, boom, you could even color it in if you wanted. If you print this correctly, there is a break there. Just like there's a break up here. In that break is all of these elements. And you can do it by the numbers also. If we zoom in on this spot right here, and we just count, right? Because like every element has 1 more proton than the element before. So if we start at row 6, cesium has 55 protons, barium has 56 protons. Oops, what? 72? Here's the break. Here's where we would do it correctly because we have an entire wall of space to work with. Here's 57. they just visually split this to kind of print on the paper better, but elements numbers 57, 58, 59, blah blah blah, 71 all should be right there, and they're not, because they're trying to make your paper print nicely. Okay, so these are all in row 6. They're just printed down below. These are all in row 7. Same thing. 87, 88, you can count. You know what comes next. It is not 104. 87, 88, 89 is down here. 90, 91, blah, 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 blah. 103, 104. This bottom row down here is all inside of row 7. Feel free to stare at that for a while if you're like, what happened? Yeah, so if you had given yourself an 8th row before, just erase it, or whatever you do. Yeah, right. They've printed it this way so that it fits nicely on your paper, but really this entire, we call it the lanthanide series, this lanthanide here, starts with lanthanum. The entire lanthanide series should be printed in this little box. The entire actinide series should be printed in this little box. They didn't, because you probably do not have a microscope that you want to use to read them. But anyways, right, okay, so actually anything, and don't worry, especially here now, I'm not going to make you draw a Bohr structure for a lanthanide or an actinide, because that would, if we're doing an actinide, that would be 7 circles, and we would be drawing tons of stuff onto it. Yeah, we will stick to drawing things with a more reasonable number of circles up here. But if you were to draw, like when you picture this in your head, if you were to draw a lanthanide, it would be 6 circles. If you were to draw an actinide, it would be 7 circles. Alright, back to here. And again, don't really worry too much about these huge things, because I'm not going to make you do a Bohr for something huge. You could do a Lewis for something huge, but we'll get to that tomorrow. And this is why Lewis is so functional, is because you can draw a Lewis structure for literally anything on this table, and it's not that wonky, right? Like, it's not as terrible as drawing something with 7 circles. Okay, so we have figured out so far that the outside has the electrons, the number of circles is based on the row of the periodic table. Everything, the row determines the number of circles. We will get back to our hydrogen example. It's got an inside right now, and we could figure out, let's do this step. How many circles will we draw for hydrogen? Hydrogen is in row 1, the first row, that top row. So our picture of hydrogen will have 1 circle. Okay. And I always feel like you can label just like that very center speck as the nucleus, and that's actually correct. So like we've actually got a circle drawn, 1 circle for hydrogen. Okay, but we're not done, because we have to put all this outside is about the electrons. So far, we've got the number of circles we're drawing, but not how many electrons. The number of electrons, so we're still on the outside. I'm just using a new piece of paper. Electrons. We figured out the number of circles on my previous page. The number of electrons The number of electrons we'll draw in a Bohr structure is based on not the row, but the column. Okay, so the number of electrons we'll draw, I should have said in each circle, is based on the column on the periodic table.